So let's go and see how this pipeline is defined exactly. First, if I go to the GitLab web interface and I click on that pipeline number here, I have this really nice little representation with all my my different stages and all the steps in each stage. So how do we define that? This is all in the GitLab CI/YAML file in the repo. Okay, so we have our stages defined here, and then, for instance, this is the little debug stage that I'm, the debug step that I'm using to show all the environment variables. You see that we just say this is part of the lint stage. We're using the container image Alpine, and we just execute env pipe sort. Super basic, but you know, for me that was kind of the hello world of GitLab steps. Now, it's a little bit more interesting to look at what happens in the build stage. So in the build stage, we have 4 steps. So we build the 4 images like RNG, WebUI, Hasher, Walker. And each time you see that weird syntax here, so this lower than, that means we're going to include or import or merge, if you will, with an existing block. And here we say star builder. Okay, so that's another interesting bit of YAML syntax. When you have star something, that means go and find the block that was defined with ampersand something, and use that. So that means that build RNG is going to be based on build with build kit, which itself is based on build base here. So we have some kind of inheritance between these different blocks. The idea is that in that build base here, we are creating a Docker registry configuration file here that has our registry token. And then we're setting a couple of variables like context and image. So context is the directory where the Docker file is located. If we go and have a quick look at the structure of the repo, we see that we have 2 directories here, containers. So Hasher, RNG, WebUI, Walker, these are the 4 components in the repo. And so each time we have a Docker file, like in each of them. And then we have Helm chart, which is going to have, guess what, the Helm chart that we use to deploy. So if I come back here for each of my components, so we're setting the credentials to access the registry. We are setting the context and image environment variables. And then depending on whether we want to build with BuildKit or Docker in Docker or Kaneko, we use a different image and different commands. So with BuildKit, we use BuildX, so that's the front end for BuildKit, and we do a BuildX build. I'm going to, a little bit later, I'm going to tell you the differences between these various build strategies. But for instance, if we wanted to build with Docker, which is something that you're probably more familiar with, we would do this docker build $context -t $image and then docker push $image. I guess that if you see these 2 commands, that probably rings a few bells, right? So with BuildKit, it's a little bit more involved because we download that BuildX frontend, and then we have this BuildX create here, but the general idea is pretty much the same. We have like a BuildX build, and BuildX build actually combines the build and the push phase. And if we were building with Kaneko, it would be pretty similar. We have this executor here, and same thing, we indicate the context, where is the Docker file, and the destination, where we want to push. Okay, so that's for the build phase. And again, I'm going to give you some more details about the various build options that we have a little bit later. Now, the deployment phase. So how does that work? That's where there is a little bit of heavy lifting, and that's the part that I expect that you will want to customize and adapt to your needs. What do we do there? So I have a basic building block here, deploy with Helm, and then I'm going to reuse it for deploy to staging and deploy to production. And the behavior will change just with these variables here. You can see that for deploy to staging, we set phase to staging, we set the namespace and the ingress host like this, like that. And for production, phase is production, the namespace is different, the ingress host is different, but that's pretty much what we do here. There is one little extra trick here in deploy to production. That extra command here, what does it do? Basically, it checks that before you try to deploy something to production, we want to make sure that it was successfully deployed to staging first. So this command right there, it's basically checking that we have a staging namespace for the exact commit that we are trying to deploy that has a label QA OK, like quality assurance OK. Okay, now let's look at this whole deploy with Helm thing. What do? We create a namespace, and that namespace will be, again, GL, and then the name of the user, the name of the project, and the Git hash. So we create that namespace if necessary. Then we add a few labels to that namespace, like created by GitLab, are we in staging or production, which project it is, which commit is it, some annotations with the commit message. We put the job URL to make it easier to access, like that I was showing you earlier. I have the URL here, so if I describe the namespace, that gives me a quick link to that CI job. That's pretty convenient. Then I'm going to get the registry credentials, and I'm going to create a secret with the registry credentials if they don't exist. Like this is, if the secrets don't exist yet, then create them. And then I'm using this good old Helm upgrade -- install, etc., etc. And here, as you can see, I am setting some extra values, like which tag I'm deploying, which registry I'm using, and which ingress I'm using. And once we've done all that, if everything went well, then I put that label QA = OK, and that's the label that I will use later as a hint to tell me, yep, we successfully deployed everything in that namespace, so we're going to allow deploying that particular commit to production. Of course, we could imagine having more complex quality assurance and more complex quality checks in place here than just this bunch of script, but you get the idea and you can customize and base your things on that. All right, so if we look now at that particular job, we're going to see all these steps. So create the namespace, label the namespace, annotate the namespace, and then create the registry secret and deploy the release. And at the end, this is showing us the URL where the release is deployed. Okay, so now we could try to push to production and see what happens. So how does that work? In the pipeline, we have here, you can see like deploy to production has only production, and conversely, deploy to staging has except production. So this is some GitLab features to say, I want this step to happen only in this specific phase or not in that specific phase. And here when we list production like that, to be clear, production is not a magic keyword in GitLab. That just means if it's a tag or branch named production. So all I have to do if I want to try and deploy to production is git tag production and then git push -- tags. And so I just pushed the production tag to GitLab Cloud Native Party. So now if I go back to my GitLab and I have a look at my CI/CD dashboard, you can see that I have my production tag here. See how it's using the same commit, and you see that we don't have the same stages. And this is on purpose. Like here, I decided, and that's completely arbitrary, you know, it's a personal decision. I decided that we would only allow to deploy to production something that was successfully pushed to staging before. So we don't build images when we push to production, because by definition these images will have been built earlier. You know, I can skip that build phase, and that's a way to make sure that I don't rebuild these images and accidentally deploy something else than I had in staging. So now if I go and take a look at that deploy to production. So deploy to production will deploy to a different namespace, and we will be able to see that namespace here, root kubecoin. So see the differences in naming. The staging namespaces are GL, root kubecoin, and the git hash. The production namespace is just root kubecoin. We could even have done something like prod root kubecoin if we like. It's completely up to us. And once the deployment is over, you can see that the URL here is root kubecoin GitLab Cloud Native Party. So we can go there. And here it's not working yet because of that DNS propagation thing. So we need to give it a few minutes, but I guarantee that in a few minutes this will work fine, and we will have the production version of the application up and running there. All right. I told you earlier that we would have a tour of the various tools and options available to build container images, and as you can see, we have many of them. Why so many? Because people have opinions, and they even have different opinions about what matters in a container build system. Some folks want fast builds, some folks want secure builds, some folks have even other constraints, like they want something that's tightly integrated with their test suites, etc., etc. So I'm going to give you a little overview. First, we have the Docker-based systems, because if you work with Docker and with Docker files, you're like, okay, I can do Docker build, Docker push, great. Now, the only problem with that is that we need to run a Docker engine. And the Docker engine needs a lot of rights, like a lot of privileges to run containers. So that will cause a few problems. Okay, first approach. If you are using a Kubernetes cluster that is using Docker as the underlying engine, you can bind mount the Docker socket. It's very easy, it's very cheap, it's pretty efficient in terms of caching, etc., etc., but it's kind of a hack, honestly. First, it only works if you are using Docker as the underlying engine, and this is going to be a less and less frequent scenario as more and more folks are moving to Containerd or Cryo or gvisor and other container runtimes. And also, when you run a build on that Docker engine, even though it runs on the same nodes that are running your Kubernetes cluster, that build is going to be invisible from the perspective of Kubernetes. So you know when the Kubernetes scheduler needs to decide on which nodes to schedule a pod, it won't know about the resources currently in use by this container build, and so it won't be able to account for that. So I don't really recommend using that. Next option, we could use some Docker in Docker. So in that case, you have a pod that runs Docker. So since Docker is running in a pod, then Kubernetes knows about it and it can account for the resources consumed by that pod. The problem is that, as I mentioned earlier, Docker needs a lot of privileges, and so we need a privileged pod, and so this is considered to be fairly insecure, except if you use things like rootless Docker or sysbox. Now, rootless Docker is not quite there yet. We're getting like closer and closer to have the possibility of running a rootless Docker in a pod. The other option is something called sysbox. And if you like the idea of a privileged pod, or rather a privileged container, but without the security risks associated to it, have a look at sysbox. It basically lets you have containers that have the features of privileged containers, but without giving them the full control to the host where they run. So that's another option. Another thing that we can do is to run our Docker engine completely separate from the Kubernetes cluster. So we have the Kubernetes cluster, and then we have this Docker engine on the side, and when we build, we send the builds to that Docker engine. So that's doable, but in terms of deployment, that's a little bit annoying because you need to have that standalone VM or sets of VMs. Now we also have some non-privileged builders. And here I picked two. I picked Canico and BuildKit. Canico because I think it was one of the first ones to be able to do that. Like, it's a builder that can run in a pod, like in a completely normal pod without any special fancy permissions. So Canico is great, except that it doesn't have caching by default. So your builds are going to take longer. And you can add some caching, but it's going to be mostly registry-based caching. Okay, what does that mean, registry-based caching? So when we cache a build, we have at least a couple of ways to do that. One way is that each time you run a build, you arrive on a completely new builder. You know, that builder has never seen your code before. So, you know, if you don't have any cache, you need to do the full Docker file build every single time. Now, registry-based caching means that when the build starts, the first thing that we do is that we get the cache from the registry, so we download that cache, and then we can execute the build process, and at the end we push back the build cache to the registry. So that's the kind of stuff that we can do with Canico. And then we can also use BuildKit, so that's with Docker BuildX and that BuildX plugin that I showed you earlier in the pipeline. And that one is pretty interesting to me because we can get some ephemeral local caching. Let me explain what I mean here. This means that I'm going to have a farm of builders. Well, at this point, it's a farm of one. And I have a local cache there. So the first time my builder has never seen my code, and so it's going to build everything and it's going to push the resulting image. So far, so good. And the next time I do a build, it's going to go back to that builder, and that builder has a cache locally, and so it can start building right away, even faster than if it had to pull the cache from the registry. It also doesn't need to push back that cache, so we're getting some really, really fast builds there. The downside is that Well, if something bad happens to that builder, you know, like the node goes down or I recycle that pod or whatever, then the cache disappears. So, you know, it's a trade-off here. Like, okay, if my pods get evicted and kicked out all the time, maybe I should rely on registry-based caching with Canico or with BuildKit, because BuildKit can also do that. Now, if my pods are going to stay here long enough, then I might want to use BuildKit to have that immediate, like very fast caching. And yes, I know that sometimes my pod will go away, and so once in a while I will have a longer build process because we will need to rebuild the cache. But maybe that's an acceptable trade-off, you know, like, do I want something which is kind of slower but always the same, or something that is generally faster but sometimes I have a spike and it's slower? It's up to you to decide. It's actually great that we have these options. And then we also have, I would say, completely Dockerless options, like even, you know, going farther than Dockerless, like this is Dockerfile-less. It's like there are some folks who are like, well, you know what, Docker files are the wrong approach. We shouldn't use that to build our images. Look, we have these options there. So for instance, Bazel. Bazel can be really awesome on huge code bases with huge teams, especially when you combine together the CI and the build process. I would like to go on a simultaneous rant and praise about Bazel. Bazel is awesome if you have a team of 200 engineers and your problem is that the whole, you know, build and unit test, etc. is now taking a few days, and you're like, okay, we can't go on like that, we need to do something about it, and you already optimized a bunch of things, and even with that it's taking a few days. Then Bazel might be the thing that's going to save you because of its extremely smart way of handling dependencies, and then you can go back to a build process that's going to take a few hours or even a few minutes. The downside of Bazel is that it requires extremely smart people to work well, and when I say that, often I see a bunch of folks being like, well, you know what, I'm super smart, so I'm going to do some Bazel and that's going to be awesome for my team. Wait a minute, I've seen so many teams out there where some, excuse my French, but some smartass somewhere decided they wanted to use Bazel and they kind of they only pushed the job halfway through. So now we have this super complex Byzantine build process based on this tool that nobody knows how to maintain because that guy is long gone and didn't leave any documentation behind him. And guess what? That's not great. It's better to have a Docker file that maybe won't be the best Docker file ever, but at least almost anyone can maintain and tinker and build it, rather than some Bazel build that is hidden behind a Jenkins file that is triggered when you push to a repo, and then nobody knows how to maintain and tweak that. So be careful with that. Again, Bazel is great when you have teams of hundreds of developers and so much code that the whole build and test suite takes days to run. Otherwise, careful with that. A few other options, Jib, this is something specific to Java world, Co in the Go world, and very often, especially for compile languages, we will find a language-specific, like framework-specific way to build images. Same thing, for instance, if you know Nix and NixOS, the distro, there are some ways to build images directly using Nix derivations, and that's also a pretty amazing and smart way to do things. But if it's not an ecosystem that you're familiar with, this is going to take a lot of time to ramp up. But as you can see, we have lots of options here. My pipeline is just showing how to leverage BuildKit, because as I was telling you earlier, I think it's a really good compromise if you have a bunch of Docker files. We can also use Docker or Canico, and you can easily switch between them if you want to see what happens. Some final words to wrap up. What I showed you here is just one possible CI/CD workflow, but there are many other possibilities. As I told you earlier, we could have different clusters for staging and production. We could even have something, like a unique staging cluster, but multiple different production clusters for different applications, or maybe the same application but deployed multiple times. If you have, for instance, one copy of your app in the US and one in Europe and one in Asia, something like that. Same thing for the domain names here. I just derived a domain name by putting together the GitLab user and the GitLab project, but you will probably want to do some more clever mapping for the different applications. But what I try to do here, instead of giving you something that is too automatic and magic and now good luck, have fun, I try to give you that pipeline here, and especially these phases here, like this whole deployment phase. That's where the magic happens, and that's this thing which I hope you will be able to customize to fit your needs, and you should absolutely feel empowered to do so and to match your requirements. There are many other things that we would need here. For instance, we might want to automatically remove older staging environments. If you want to do that, have a look at kubejanitor. It can automatically remove older resources. Another thing that we can do is think about permissions, how to not give GitLab the keys to the castle, as I was telling earlier. And here again, this is going to depend of what you want to achieve, depending on whether you have separate clusters, etc. A pretty common pattern will be to have a kubeconfig file, and then in our options here, in the variables for GitLab, we add a variable, we call it kubeconfig. Here you copy paste your kubeconfig, like your literal kubeconfig that we have here. You copy paste that right there, and then you set it, of type file. What will this do? Well, when you have a variable of type file, this means that kubeconfig won't have directly this content here. Kubeconfig will be the path to a file that has this content. And so in that case, all the tools that we are using in our pipeline are going to notice, you have a kubeconfig file, so I'm going to use that to communicate with the cluster. Another thing, you might wonder, hey, why aren't we using GitLab's wonderful Kubernetes integration? Because if we go to GitLab and we go to our project here, there is add Kubernetes cluster, and GitLab actually has some pretty interesting integration here. So why didn't I use that? Because this is taking you to a more opinionated approach where things are going to happen in a specific way. And here I wanted to give you something a little bit more open, giving you a little bit more options and choice about how you want to build and deploy your applications. But you should also feel free to experiment with that. It has a more all-in-one approach. If I wanted to use that integration personally, I think that what I would do in that case is have a Kubernetes cluster dedicated to GitLab and have every component on that cluster completely dedicated to GitLab, run my staging environments there, and then deploy to production to other clusters. So that's another way to do things. Well, that's all, folks. Thanks for staying with us until the end. I hope that this was useful to you and that it will inspire you to create your own custom CI/CD pipeline, whether it's with GitLab or something else, and to run things on Kubernetes, whether it's with LKE, like Linode Kubernetes Engine, on some other Kubernetes cluster. One last thing, as I was telling you earlier, on the cloud, you get charged for what you use, but you also get charged for what you forget to shut down. So personally, I'm going now to shut down these clusters that I created earlier, so I can use the web interface here, you know, I can go to that CNP cluster here, Cloud Native Party. Yes, delete that, delete cluster. Or since I created a cluster with the CLI earlier, I can also use that, and I can use Linode CLI, LKE, and then clusters list. There we go, and cluster delete, and then you have to put that cluster ID right there. This is going to delete the cluster, this is going to delete the nodes, this is going to delete the load balancer. One thing that I should mention as well is that by default, Linode tries to make sure that they won't lose your data, which means that every persistent volume that was created in these clusters has been created with the retain policy. Like, wait, what is this about persistent volumes, retain policy? This means that all the volumes that have been created are retained, like they are not automatically destroyed, so that basically if you destroy the wrong cluster by mistake, you don't lose all your data. So it means that you will also want to delete these volumes here. And so once the cluster is down, we can go here and delete them. If you have a lot of volumes, you can also easily script this deletion phase. And I have a few others corresponding to another cluster maybe, so I'm going to clean that up later. But yeah, don't forget to clean up your cloud resources and have fun setting up CI/CD pipelines with GitLab on LKE. Bye!